Hello everyone, my name is Kailash, and in this video we're we're about to present a distributed, highly scalable and distributed system that we're hosting on the web. And the app this our team consists of Kailash, Sai Supraja, Sharanya, and Soumya. Now, before we get into the details about the implementation, I will give you a brief overview of the architecture of our system. The the architecture consists of the system is a three it's a three-tier architecture. There's a front end, there's a back end, and the persistence layer. On the front end, between the user and our front end, there's a load balancer, and between the front end and the back end, there's another load balancer. Now, the load balancer, as you may already know, is a is an application that distributes the so it accepts incoming traffic and then distributes it across several different consumers. So in our case, the load balancer, it accepts traffic from the front end server and distributes the traffic among the several backend hosts that we have. Now, on the backend, we are using Node.js and Redis for uh, caching, and the um, the the backend sends traffic through to the database through through an Apache Kafka message broker. Now, this whole system was is hosted on the cloud on AWS, and on the backend we are using a NoSQL database, MongoDB. Now, I will go into some. I'll go into uh, our the thought process behind using some of these technologies. First of all, on the front end, we are using React. Why React? It's React is a is a JavaScript uh, library, and the it has the concept of components. This is a very it's the future of web development. It's easy to read and understand views. The most important thing though is that if the application has a lot of data that's constantly changing, then React is the is a very good choice. That's the reason being that React uses a, a diff algorithm that checks instead of changing the entire DOM tree, it checks its virtual DOM against the physical DOM for any changes, and then simply updates the nodes that have been changed. So, like I said, the virtual DOM is it's a it, it's basically a copy of the physical DOM that's maintained by the React library, and it just checks the differences between the virtual DOM and the full DOM. Now, again, in React, data mutation is handled very efficiently. The through the virtual DOM and the subtrees, etc. It computes a minimal set of DOM mutations and then adds them into a queue and batch executes them together. Now, why NoSQL? NoSQL reason behind choosing NoSQL is a NoSQL database like MongoDB is that because non-relational databases are easier to scale. Our The idea behind this system is that it should be highly scalable, and MongoDB, a NoSQL database, is highly scalable. Now, other reasons are that it's an open source database. There is support for replication and eventual consistency. Kafka. The reason behind choosing Kafka is that, for one, I'll quickly go into the background of Kafka. It was originally developed at LinkedIn in 2011. It is a whole platform right now that allows the users to redundantly store vast amounts of data. It has a message bus and with huge throughput, millions of transactions per second. It also uses real-time stream processing on the data and goes through all of it at once. Um, our system being a highly scalable and distributed system, it's split up into multiple hosts. Now, all these hosts can work together in a cluster, and it will appear to the end user as if it's a single node. Now, Kafka lends itself easily to highly distributed and horizontally scalable fault-tolerant systems. It is a The application is JVM based. It's written in Java and Scala. I'm sorry.
Hi, this is Soumya Gaurishankar, and I'm going to be talking about the important strategies that need to be followed while implementing a three-tier architecture while hosting a website. So I've listed a few strategies here, and the first one is using React as the view component in an MVC architecture. React components are very effective in managing different parts of a single page, and because React uses reusable components, it is the website itself becomes far more responsive. Now, what is React? React is a JavaScript library, and it is used for building user interfaces. It can be used as a base in the development of a single page or mobile application, and it is very optimal whenever there is rapidly changing data on screen, and this rapidly changing data needs to be fetched. The quickest method will be React. So React is very effective, and it is yeah, basically because it's the quickest method to fetch rapidly changing data that needs to be recorded. And so whenever there is data being stored in a DB, and if the DB is an SQL database, SQL caching techniques can be implemented, and the website becomes far more responsive, and it becomes faster. Now, what is a caching technique? Caching technique is basically storing the output of a DB query, and whenever there is the same query or a similar query that is being performed on the data, the query is not done on the directly on the database. So because the query is the same and the result is also going to be the same, the output of this query can be fetched from the cache itself. So for this, Redis can be used. So Redis is a remote dictionary server, and it is an in-memory data structure. Uh, in-memory data structure, and it implements a distributed in-memory key-value database with optional durability, of course. And because SQL caching is implemented, it improves the overall performance of data query drastically, and because of this, huge data can be read much faster. And MySQL is effective in maintaining the ACID properties of data, and hence it should be used for all transactional data. So whenever there is transactional data that is being used, say for example in banking applications, SQL DB is going to be used. And whenever there is SQL DB that is going to be used, you can implement SQL caching technique, and for that Redis can be used. That is another important strategy that can be followed. And one more strategy is using Kafka. Kafka is a strategy that can be used for effective load balancing. So whenever you anticipate huge amount of incoming requests to your website, and the load needs to be balanced, Kafka can be used. And also, whenever you want to have all requests honored and even one request should not be dropped, Kafka should be implemented. Now, what is Kafka? It is an open source stream processing software platform, and it was initially developed by LinkedIn, and it was later donated to Apache software. And it is written, Kafka is written in Scala and Java. And it is a high throughput, low latency platform for handling real time data feeds. And it is also effective in load balancing, and it because of this it makes the entire system horizontally scalable. And because of its high throughput, the performance gets a hit, and that is a downside of using Kafka. So you need to choose between performance and throughput. And and why the performance decreases? It decreases because of the overhead of not losing even one request. So that is something the uh, that needs to be considered whenever a website is being hosted. And there are many other strategies that can be followed. And in the upcoming slides, the other strategies will be discussed.
Hi everyone, this is Sai Supraja Mala and I'll be discussing about the frameworks that we have used for unit testing, load testing and session maintenance. So for the unit testing part, we have used Mocha and Chai together. The smallest parts of the application are called units. Testing of those units to check whether it is fit for use or not is called unit testing. Mocha and Chai are two JavaScript frameworks that are for unit testing and that we have used in this particular application. Mocha provides functions that are executed according in a specific order and that logs their results to the terminal window. Mocha gives you the flexibility to run asynchronous or synchronous code serially. Any uncaught exceptions are shown alongside the test case in which it was thrown, making it easy to identify exactly what failed and why. Coming to Chai, it is an assertion library that is often used alongside Mocha. It provides functions and methods that help you compare the output of a certain test with its expected value. Assertion with Chai provides natural language assertions, expressive and readable style. And there are mainly two popular way of assertions in Chai, expect and should. The expect interface provides function for assertion, and the should interface extends each object with a should property for assertion. Should property gets added to the object.prototype so that all object can access it through property chain. Apache JMeter. So for the load testing, we have used Apache JMeter in this application, and this test is useful for determining and preceding the system. Under the top load, it was aimed to work under. Apache JMeter used as a load testing tool for analyzing and measuring the performance of a variety of services with a focus on web application. So the reasons for choosing JMeter is it's an open source application. It has a user friendly GUI. It is platform independent and it supports various testing approach. And it and the test results are also very easy to understand. Passport.js. So for the session maintenance, we have used Passport.js in this application, and session maintenance is the rule set that governs interactions between a web-based application and users. Browsers and websites use HTTP to communicate, and a web session is a series of HTTP request and response transactions created by the same user. Passport is authentication middleware for Node.js. It is extremely flexible and modular. Passport can be unobstrusively dropped into any kind of express-based web application, and that was one of the reasons we chose Passport.js, and a comprehensive set of strategies support authentication using a username and password, Facebook, Twitter, and more. It is designed to serve a singular purpose, authenticate requests. The rest will be continued by Serenia. Thank you.
Hello, my name is Saranya. Today I'm going to talk about two different databases, MySQL and MongoDB, which Soumya was talking before. I'm just going to elaborate on that. MySQL is a popular open source relational database management system, RDBMS, that has been developed by Oracle Corporation. Like any other relational systems, MySQL stores data in tables and uses structured query language (SQL) for database access. In MySQL, you predefine your database schema based on your requirements and set up rules to govern these relations between the fields. And in MySQL, related information may be stored in different tables, but they associate through the joins. In this way, the data duplication can be minimized. The next one is MongoDB. MongoDB is an open source database that has been developed by MongoDB Incorporation. MongoDB stores data in JSON-like documents that can vary in structure. Related information is stored together for fast query access through MongoDB query language. It uses dynamic schemas, meaning that you can create records without having to define the structure, such as fields or type of their values. You can change the structure of records simply by adding new fields or deleting existing ones. This data model gives you the ability to represent hierarchical relationships, to store arrays and other more complex structures. So what are the differences between these two databases? MySQL represents data in tables and rows, and MongoDB represents data as collection of JSON documents. MySQL is a structured query language, and MongoDB uses object querying. One of the best things about MySQL and relational databases in general, it supports join operation. MongoDB, it does not support joins, but it does multi-dimensional data types such as arrays and even other documents. Placing one document inside another is referred to as embedding. MySQL refers you to define your tables and columns even before you can store anything. And every row in a table must have the same columns. But MongoDB is schema free. That means it allows you to create documents without having to define the structure of the document first. These documents can easily be changed by adding or deleting fields. And next one we talk about is the replication. MySQL supports master-slave replication and master-master replication. Multi-source replication allows you to replicate from several masters in parallel. MongoDB supports built-in replication, sharding, and auto-elections. Using auto-elections, we can set up secondary database to automatically take over if the primary database fails. Sharding allows for horizontal scaling, which is difficult to implement in MySQL. MongoDB uses replica sets to create multiple copies of the data. Each member of the replica set can have a role of a primary or secondary at any point in the process. Reads and writes are done on the primary replica by default and then replicated to the secondary replicas. Both MySQL and MongoDB use indexes to allow them to find data quickly. With MySQL, if an index is not defined, the database engine must scan the entire table to find all the relevant rows. But in MongoDB, if an index is not found, every document within a collection must be scanned to select the documents that provide the match to the query statement. So how are the queries different? So let's take an example. If selecting records from the customer table, we use select star from customer in MySQL query, but in MongoDB we use db.customer.find. In inserting records into the table, MySQL we write it as insert into customer and then column name and then values. In MongoDB, we just write it as db.customer.insert and then key as a key value pair. Thank you.